Hello everyone, welcome back to my channel Study With Me. Today I'm going to talk about Chemistry Standard Level Paper 1, May 2022. It would be Time Zone 2. So if you find this video is helpful, don't forget to subscribe and let your other friend knows about my channel so you guys can study together. And now let's get started. What is the concentration of chloride ions in mole decimeter cube in a solution formed by mixing 200 centimeter cube of 1 molar HCl with 200 centimeter cube of 5 molar of HCl? Okay, we need to calculate the number of mole of Cl minus in HCl by doing C times V. 1 times 0.2, which is 0.2 mole, and Cl minus in NaCl, that would be 5 times 0.2, which is 1 mole. So the concentration is 5 molar and the volume is 200 centimeter cube, so divided by 1000 to decimeter cube is 0.2. Okay, so the N total will be 1.2 mole. So for V total, I will just write down here. So V total, it's 400 centimeter cube, which is 0.4 decimeter cube. So for concentration, that would be N total divided by V total, which is 1.2 divided by 0.4. It's 3 mole per decimeter cube. 30 grams of an organic compound produced 44 grams CO2 and 18 grams of H2O as the only combustion product. Which of the following is the empirical formula for this compound? So first we need to find the mole of in CO2, which is 44 divided by 44 as well, and it's 1 mole. So for CO2, it has 1 C, so it contains 1 mole C. And for mole of hydrogen in H2O, that would be 18 divided by 18 molar mass of H2O. 18 comes from the mass of H2O, so you get 1 mole, but it contains 2 mole hydrogen because it has 2 H. Okay, so then we calculate total mass of C and H. So 1 C, so mole times molar mass or relative atomic mass of C, and then plus 2 mole H, so 2 times relative atomic mass of H is 1, so that would be 16 grams. The total is 30 grams. Therefore, there is another element, which is oxygen. It contains in this organic compound. So oxygen, the mole is 16 divided by 16. So mass of oxygen 16, and the relative atomic mass of oxygen is 16. So you get 1 mole of oxygen. So the empirical formula would be CH2O. All right. Number 3. Which graph represents the relationship between the amount of gas N and the absolute temperature T with all other variables in the ideal gas equation, PV equal nRT held constant? Okay. The equation is PV and RT. Let's arrange this so T would be the subject by dividing with NR. So this will be finish. So you get T, PV equal to NR. Okay, R is always constant. Okay, and from this equation, PV are also constant. Therefore, these three, okay, it's a K. So T equals to K divided by N, or T is inversely proportional to N. That would be B curve. Which equation represents the deposition in iodine? The process of deposition involves the direct transition of a substance from the gas phase to the solid phase. So the answer would be B. Which experimental results support the theory that electron exists in discrete energy levels? It's emission spectra. Emission spectra shows discrete lines when electrons transitions between energy levels, proving electron exists in distinct energy levels within atoms. What is the relative atomic mass of an element with the following mass spectrum? So here is 80%, that would be 0.8, and times this mass to Z ratio, so times 23 plus 0.2, 20%, times 28, then you will get 24. Three elements X, Y, Z are in the same period of the periodic table. The relative sizes of their atoms are represented by the diagram. So it's smaller, therefore the nuclear charge increases. Okay, and if the nuclear charge increases, obviously ionization energy also increases. And this is left to the right. You know, left is the group 1 metal. Metal tends to form basic oxide and then moves to amphoteric and move to acidic oxide, because non-metal forms acidic oxide. Therefore, the answer is C. So nuclear charge increases, so ionization, nuclear charge increases, so X smaller than Y, smaller than Z, and then ionization increases as well, so it will be the same. And then for Z is the most acidic, because we can say that this is from the left to the right. So right side non-metal tends to form more acidic oxide, and left side metal tends to form basic oxide, and then in the middle it's an amphoteric, is a neutral. Okay, so which element is found in the fourth group 6th period of the periodic table? Let's see the periodic table. Okay, these are the periodic table. All right, so the question is fourth group, so fourth group, period 6, so HF. Okay, so hafnium. Which statements best describes the intramolecular bonding in HCN? HCN, that would be like this. So it's also H plus with Cn minus. So electrostatic attraction between H plus and Cn minus. So but H and Cn, they are all non-metals, so it's not electrostatic. Electrostatic is for non-metal and metal. It's an ionic compound, but HCN is not an ionic compound, so no. Hydrogen bonding, okay, so hydrogen bonding is between H and Cn, okay, sorry, H and N, but here H with C, so it's not a hydrogen bonding. Hydrogen bonding should be direct bond between H and N. The third one, van der Waals forces and hydrogen bonding. There is no hydrogen bonding, so of course it's D. Electrostatic attraction between pairs of electrons. Of course, pairs of electrons is the covalent bond. So number 10, what is the type of bonding in a compound that has high boiling and melting points, poor electrical conductivity, and low solubility in water? In giant covalent structures, atoms are bonded together by strong covalent bond, forming a 3D network. For example, diamond and SiO2. Diamond and SiO2, silicon oxide, they have high melting and boiling points because of large amount of energy is required to break the strong covalent bonds that holding atom together. They do not conduct electricity well because there are no free moving charged particles like ions or electrons within the structure. So it is a giant covalent for the answer number 10. What is the name of the compound with formula Ti3PO42? So we need to making it into ion, phosphate ion. So these three belong to phosphate ion and these two belong to Ti. So Ti is 2 plus because it's transition metal. So 2 plus it comes with this. Alright, so the answer is B. What is the main interaction between liquid CH4 molecule? So CH4, dipole moment is cancelled out, therefore is non-polar molecule, so it has only London diffraction forces. Unless the dipole moment is not cancelled out or it has a lone pair, that would be dipole-dipole forces. Or if there is hydrogen bonding, which is between H with nitrogen, oxygen, or fluorine, that would be hydrogen bonding. What is correct about energy changes during bond breaking and bond formation? Bond breaking, energy is absorbed. So when the energy is absorbed is an endothermic, so between C and D. And delta H will be positive because it is an increase in enthalpy. Okay? And for bond forming, energy is released. So it's exothermic and decrease in enthalpy because product will have higher enthalpy and then release the energy becomes lower enthalpy in the reactant. So delta H is negative because it goes down. So the answer is C. Which combination of which combination of delta H1, delta H2, delta H3 would give the enthalpy of the reaction? So we need CS2 liquid. That would be on the right side, but here is on the left side. So definitely we need to reverse. And 3O2, if you're not really sure, just leave it first. Let's see CO2. CO2 is on the right side. CO2 is on the right side. So this one is stay. 2SO2. 2SO2 is on the right side. This one is on the right side as well. But the coefficient here is 2. Here is 1. Therefore, we need to multiply by 2. Let's rewrite. Okay, C, S plus O2 gas produce CO2 gas and times 2, 2S solid plus O2 gas produce 2S2 SO2 gas and reverse. So CS2 liquid produce CS and 2S solid. Okay, so that would be 3O2 here, we need it, and C, we don't need it, and CO2, we need it, and S, we don't need it, and CS, we need it, and 2SO2, we need it. So therefore, delta H will be delta H1. So this will be times 2, yeah? 2 times delta H2. And this one will be negative delta H3. Okay? So plus 2 times delta H2, because times 2. And minus delta H3, because it's reverse. Alright? Which statement is correct about identical pieces of magnesium add to two solutions, X and Y, containing hydrochloric acid at the same temperature? So both of them is at the same amount of magnesium, but it has a different concentration. Solution X is more concentrated than solution Y, and solution Y has more volume compared to solution X. The answer is A. Why? Solution X has higher concentration. It means faster reaction, as there are more reactant particles in solution X to collide with magnesium. So faster reaction, so it will reach faster the maximum temperature. And for solution Y, has a larger volume, makes more space for the heat to dissipate, potentially lowering the maximum temperature that would be reached. That's why solution X will reach a higher maximum temperature. Why does a reaction for a sample of gases at constant temperature occur faster at higher pressure? Because if higher pressure, gas molecules are closer together, so collision will happen more frequently. A reaction has an activation energy of 40 kJ per mole and an enthalpy change of negative 60 kJ per mole. So delta H is a negative, therefore it is exothermic. So this one is not, so between A and B. And the activation energy is 40 kilojoule per mole. So if you calculate, this one is between this number, so it's around 40 for the activation energy. Well, let's see for C first. So 100 to 140, so it's definitely 40 kilojoule per mole. And let's see for delta H. Okay, so here is delta H and this one is delta H. So delta H is only negative 60, so from 100 to around 40, so this one is definitely more than 60, so the answer is C. The equilibrium constant Kc for the reaction 2A plus 4B produce 2C plus 4D has the value of 4. What is the value of Kc for the reaction below at the same temperature? As you can see that C becomes a reactant, which is before a product, so it's reverse. And then you also see that the coefficient is double, so when it's double, Kc will be squared, and reverse Kc to the power negative 1, so 1 over 4 Kc to the power negative 1, and squared, sorry, it's not squared, half of the coefficient is square root, okay, sorry, so square root, that would be 1 over 2, it's 0.5. Which of these 0.001 mole per decimeter cube solution is most likely to have a pH of 11.3? Okay, we have this, and this is not gonna be the answer because it's a weak acid, so the pH will be slightly, or closer to 7, so it's not 11.3. And let's check for the A. It's a strong base, completely dissociate, and it has 2 OH, so 2 OH minus. Okay, so the 0.001 times 2, that would be 0.002, so POH would be negative log times 2 times 10 to the power negative 3. You don't have calculator here, so let's leave this first. Let's do for C. C is also a strong base that would dissociate completely, so NaOH, it has 1 OH, so concentration of OH will be 10 to the power negative 3, okay, and POH will be 3, so pH would be 14 minus 3, and it's 11, directly, it's 11. NH4OH, it's a weak base, so it's partially dissociate, so it's also close to 7. So this is not the answer. So now we left with A and C. C, it's 11. We need 11.3. So definitely will be A because the concentration of OH minus is higher. So without a calculator, you can estimate CaOH, maybe that would be around something or slightly greater compared to NaOH because it has 2 OH minus. All right. So next, what is the strongest acid in the equation below? So when we look to this equation, we can directly think Kc will be H2ASO4 and H3O plus. I can say this is Ka as well because it's acid, and then divided by H3ASO4. Okay, H2O will not be in the equation because it doesn't give any effect. So Ka is 4.5 times 10 to the power negative 4. Okay, so if Ka relatively large, acid will dissociate more completely. So if Ka is big, acid will tends to dissociate more completely. So it means that would be a strong acid. If Ka is small, so it will dissociate less, so it is a weaker acid. Okay, so as you can see, the concentration of H3O plus is in the numerator, so indicating that a higher concentration of H3O plus correspondent to a larger Ka, meaning stronger Ka. So in the equation, H3O plus is produced in the dissociation of H3ASO4. Thus, we can say that H3O plus is the strongest acid. Which species could be reduced to form NO2? So NO2, if we check the oxidation state, is -4, and this will be +4 because O is -2 times 2 is -4. So we'll see it's reduction. N2, it's 0, so it's oxidation. NO3 minus, this -6, so equal to -1, so N should be +5. So +5 to +4 is a reduction. And for HNO2, let's check, -4, H plus 1, N would be +3, oxidation. And for NO, -2, +2, oxidation as well. Which combination best describes what is happening to chloromethane CH3Cl in the equation below? The reaction replaces chlorine atom in a chloromethane with a hydrogen atom, so it's a substitution. And you know, oxidation and reaction, if number of oxygen increase, it will be an oxidation. If a number of H decrease, that would be a reduction. And you can see here, number of hydrogen atoms increases while chlorine atom decreases in the product, so that would be a reduction. The arrows represent electron flow in the diagram. What does terminal X on the battery represent? This one is voltaic cell. Okay, so electron flows from the negative to positive in the wire. So this will be positive and then this will be negative. So what about X, terminal X? So is a voltaic cell, so positive electrode indicates cathode, so the answer would be C. How many dechlorinated butane isomers can be formed by the halogenation of butane with excess Cl2 in the presence of UV light? finding number of isomers. There is no other way except you try to draw the structure and then find any kind of possibilities that doesn't have the same IUPAC name. That's the only way you have to do. It's a lot of work, but what can we do? So the first one is CH3, CH2, CH, and then CH2. So I will put Cl here. This will be 1.2 dichloro. I will just put B here as a butane. Okay. And then CH2, 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 CH2. I will put Cl here. That would be 1.4. Okay. Dichlorobutane. Okay. That would be dichloro, because it always have 2 Cl. The third one will be CH3, C, and Cl. CH2, CH2, and Cl. That would be 2.4, yeah, 2.4 dichlorobutane. And the fourth one will be CH3, C, Cl, CH2, CH2, Cl. That would be 2.4. Yeah, 2.4. Okay, so I will put Cl in another place. So Cl will be here, and then CH2, CH2, Cl. Okay, so still the same. So what about Cl1 and 3? Yeah, okay. So 1.3 dichlorobutane. Okay, so these four are not the same. So now Cl, Cl, CH2, CH2, CH3. That would be 1.1 dichlorobutane. And then the last one would be CH2, and I'll put Cl, Cl, CH2, CH3. So that would be 2.2 dichlorobutane. So we have 6. You cannot put here because that would be 2.2 as well. So that's the only way you can do for finding isomers. Which structure represents a repeating unit of a polymer formed from propene? Okay, so propene is CH3CH2. Okay, so to make the polymer, let's start from CH3 and C and H, and I move to CH2 and then this. So A, which is a homologous series. Homologous series should be differ from next by repeating CH2 unit consistently or adding CH2. So that would be B. If you add CH2, so plus 1C plus 2H C3H4 plus 1C plus 2H C4H6. Which reaction mechanism are typical for alcohol and halogenoalkanes? Okay, so it's a nucleophilic substitution, because alcohol and halogenoalkane, it's a substitution, and is the alcohol is acting as a nucleophile, so it's a nucleophilic substitution. How many signal are observed in the HNMR spectrum of this compound? Is it symmetrical? So it will be definitely only one, because it has only one H environment. Number 29, what is the uncertainty in centimeter cube of this measurement? Okay, so based on the IBMR scheme, the answer is C. Okay, but the smaller gradation is 1 centimeter cube, because it's 50 to 60. It has 10 ticks on the scale from 50 to 60, and the rule of thumb is uncertainty is the smallest deviation. So that would be half of 1 centimeter cube, which is plus negative 0.5 centimeter cube. That is coming from my perception. And based on the report as well, that would be 0.5 centimeter cube as well. So C, it's not very the answer based on my perspective or point of view. So number 30, 20 centimeter cube of 1 mole decimeter cube sulfuric acid was added dropwise to 20 centimeter cube of 1 molar barium hydroxide, producing a precipitate of barium sulfate. Okay, which graph represent a plot of conductivity against volume of acid added? It will be B graph. It indicates decrease in conductivity as more sulfuric acid is added. The more precipitation of barium sulfate will be produced. Therefore, this precipitation will remove ions from the solution, so the conductivity will keep decreasing. The more you add the dropwise, the more the precipitation will form, and the more ions that is available in the solution will be consumed. Therefore, it will keep going to decrease. So this will be the best graph represent for number 30. All right, so that's all for the SL paper 1 May 2022 for time zone 2. If you find this video is helpful, don't forget to subscribe, and please let your other friend knows about my channel as well, so that would be very helpful to support me for making more past year papers, and you guys also can study together and being helpful to your friend as well by letting my channel that is explaining past papers. Okay, and thank you for watching, and bye for now.